Before we go any further in chapter 5 into 5.2, we need to talk about sigma notation. Probably would have seen this in pre-calc. Sometimes it's called summation notation. It's going to be really key once we get to 5.2. So let's review just kind of how sigma notation works just for a moment, and then even mention some key formulas that come from it. So what is sigma notation or summation notation? There's an example. That symbol you see is the capital Greek letter for sigma, the equivalent of their letter S. Looked like that. Kind of looks like an E. You know, maybe you've seen that symbol out. You've been driving by SDSU on a frat house or something. Okay. So the idea is that's telling us to sum a bunch of numbers, to add them. What we're going to do, the expression next to it will help us calculate those numbers, and the notation around the sigma, right? So it's saying I equals 1, that's where we start. The number on top is where we stop. So we'd say, okay, to calculate this value, we'd begin by plugging 1 into the expression, find what that is. Then we'd add and plug in 2, plug in all of the integers until we get to 5. That would look like this. So plugging in 1 would give us 3, plugging in 2 would give us 5, plugging in 3 and 4 and 5 would give us 11. So at that point we would stop. And from there, right, we could add all those together. In this case, you'd end up with 35. Not that that's really so important. It's more like, how do we read that notation and how do we work with it? Okay. So that's your review of sigma notation. Now let's look at a few key formulas that we're going to need in 5.2. The first one is the summation from I equals 1 to n of simply I. So what would that mean? You know, we're adding up the numbers from 1 up to n. So, you know, when you plug in, there's nothing really to do. You're just plugging in 1, then plugging in 2, then plugging in 3, all the way until whatever your last number was. We'll just call it n. Turns out there's a formula for this. If you're adding the first n integers, the formula is n times n plus 1 all over 2. Maybe you've seen that before. Maybe that looks kind of familiar. I'm not going to explain why it is, you know, where that formula comes from. We just need to know. Okay. The next formula is for I squared, from the summation from I equals 1 to n of I squared. So in this case, we'd be adding all of the squares, 1 plus 4 plus 9, and so on until we got to n squared. Turns out there's slightly more complicated formula for this one. The summation for I squared is n times n plus 1 times 2n plus 1 all over 6. Okay, all right, there you are. Next, and the last power of I, will need I cubed. So we're adding up all of the cubes. And I'll just go ahead and tell you the formula right away. There it is, n squared times n plus 1 squared all over 4. Now, what's kind of interesting, you know, at the end, we just need to know what these formulas are. But it's kind of interesting, right? If you compare this formula to this one, it's exactly the square, n squared n plus 1 squared over 4. How bizarre is that? Yet it's the cube of the numbers. That's kind of really strange. Anyway, there you go. The last formula is when we apply a summation to a constant. So let's say the summation from I equals 1 to n for the constant c. How would that work? Well, there's no I to plug in the numbers. So you'd simply end up adding c to itself, and you would do that n times, since there are n numbers, right? I equals 1, I equals 2, I equals 3, all the way up to n. You'd end up adding c to itself n times. Well, if you do that, if you add a number to itself n times, that's the same as c times n. Okay, so please take note of each of these 4 formulas, and I'll see you guys in 5.2.